So we're coming to the last presentation before the panel. So I'm happy to have with us Wenyi Gong. She's the head of overseas technical support at Jolywood, and she will talk about breaking the limits, windproof modules, redefining solar reliability in an era of extreme weather, and it's only getting worse. Wenyi, the floor is yours.
Okay, thank you. Let me share my screen. So thank you for joining me today. Today I will presenting our Windproof solution facing the more and more challenging extreme weather conditions. So we will firstly review the threats of these extreme weathers and also the limitation of the conventional module in different application, and also our solution, the concept data and some real world cases. So our planet is sending us very urgent signals. So the global records of the hottest year continue to be broken, and also the extreme weather events are raising more frequency and also the severity. So in this climate emergency, the solar energy stands as our most viable solution. But ironically, this very climate we are trying to save now threatens also the technology meant to be rescue us. So these extreme weathers events, such as the blizzard, the hailstorm, and typhoon, that can have the devastating effect on the PV modules. And our traditional module actually designed to develop in a much milder climate conditions. And we can see, so actually except for the frequency of the events, we can also see like the severity, for example, for the hail size, it has already exceeding like 50 millimeter in some regions, and also the hurricane level is becoming more and more much higher than previous years. Besides, because the better use of the lands for more PV, so a lot of power plants are installed in mountains and desert and offshore, and also bring a lot of challenges. For example, the heavy wind and those dynamic loads caused by those heavy wave heights for the offshore systems. So while these technical requirements for the PV module become more and more demanding, the module design actually has the opposite trend of development. So actually we can see like the module size become larger and larger. So it's like almost 150% larger than 10 years ago. And also all parameters along the structure, for example, the frame height, the seaside height, the framework thickness. So everything become thinner and shorter for the lower cost. So as a result, we can see the average module load is reduced from like 300 Pascal to 1500 Pascal. So it also clearly declining, and also both for the average load and also the pass rate in the laboratory. So it's not only so it's not a technical issue, but also a financial issue. So we've seen there are a lot of damage situation in the past few years due to all kinds of disasters. So for example, like in last year, the Typhoon Yagi, which has the category 17, with almost 60 meter per second wind speed, and it caused for some PV system, it caused over 60% module damage, and it caused for only for the all PV power plants in China, it caused over 2 billion RMB damages for the properties. So except for the frame and the structure damage, the glass-related risk for the bifacial dual glass module also arise due to the use of the heat strengthened glass and reduce the thickness and also the ultra large dimensions. So we also see there are a lot of different causes for the breakage for the dual glass module. I believe we should the audience should very familiar with this. So we can see there's kind of impossible trimmer for low cost, high quality, and also the high performance. So actually, we are trying to breaking this impossible trimmer and looking for our solution by the innovation, which is the Windproof solution. So it is a composition with the fully tempered front glass and the backbone steel frame and with the J-TOPCon PV cell and also the transparent mesh backsheet. So it's actually the integration of the three core technology, our self-patent by Jolywood ourselves. So for the core of the high efficiency is our J-TOPCon cell. So actually Jolywood pioneered in the PVD technology for the depositing the polylayer into the J-TOPCon cell, and it can help to eliminate the steps for the wraparound issue and also to make the whole production process more elegant and improve the yield. And also can help to enhance the cell efficiency. So except that, we also own our JCM technology, which is a special injected metallization process that can optimize the sintering temperature and also reducing the contact resistance and help to improve the cell efficiency. And most importantly, it can help to enhance the resistance for the TOPCon cell to the damp heat issue and also the humidity and the corrosion. So the cornerstone of the high reliability is the backbone steel frame. So here is a cross-section of our backbone steel frame. So we can see there are some, it's very different from the conventional aluminum frame. So the A side here has a much lower height. It's 1 millimeter lower height, so it can prevent the silicon gel overflow and also to mitigate the dust shading on the edge. And for the B side, we can see there's a special design. So it's combined the rigidity and also the flexibility. So it can provide elasticity. So like providing buffer when the module is withstand some external stress. So it can create some synchronized deformation with also the glass inside and the upper side of the cavity. And we have this specially designed double beam structure. So we have this load bearer beam here to support the laminates and can provide the very good loading performance. And we also have this reinforcing beam at the C side. So with this reinforced beam, we can have a thinner thickness and also with the same strength and a shorter C side, which will lead to a smaller shading area at the back side. And it can actually provide a higher bifaciality ratio for that. So the material strength is like 3 times higher than the conventional aluminum frame, and also the tear resistance is can be enhanced by more than 78%. So another very important element for our Windproof solution is the transparent backsheet. So with our Jolywood Halberd tech, the backsheet applies the reflective mesh coating at the backside of the backsheet. So it can enable the secondary light reflection and can enhance the light capture. Besides, with our material and process innovation, and also especially the material innovation, the reliability of the transparent backsheet can reach passing like more than 500 kilowatt per square meter UV exposed, and can resist the damp heat environment, and there's no concern. I know like a lot of customer are concerned about the backsheet solution especially for the TOPCon. However, after our innovation and also verification test, so I think it can prove that our transparent backsheet is quite doable for our all kinds of scenario application. So this backsheet structure, the glass backsheet structure, can also provide ultra high efficiency of the thermal dissipation. So it's kind of like a breathable solution polymer that can provide a much better temperature performance. So it can remove the internal generated acetic acid, and also help to improve the like temperature coefficient and other many important temperature characteristics. So with the help of the transparent backsheet, now we can use a thicker front glass to protect the module. So with the thickness over 2.5 millimeter, actually the glass can go through the fully tempered process, which means there's a higher surface compressive stress, which can enhance the impact resistance and make it more resistance and against all kinds of the mechanical impacts and also the thermal changes, which the 2 millimeter front glass for the dual glass module cannot achieve. So with all these elements, our windproof solution has 3 core technology, including the extreme the reliability, and also a higher power yield, and at the same time, it's more eco-friendly and environmental adaptability solution. So here we can see for the hail resistance capability, we performed the verification test between the dual glass with the 1.6 millimeter thick glass, and also our windproof solution, the 2.8 millimeter fully tempered glass, and with different framing solution. So we can see the actually with the application of the backbone steel frame, the hail resistance can be enhanced, and also with combination of the fully tempered glass, the whole hail resistance can go up to even 75 millimeter diameter ice ball with certain angle, and for the 90-degree it can withstand 55 millimeter diameter ice ball. So it also has a higher mechanical load. So during the loads, here is the simulation result in comparison the backbone steel frame and also the aluminum. So we can see, because of the double beam structure, actually it can provide more synchronized deformation when the front glass, the front surface is pressed by the external stress, and while this closed cavity of the conventional aluminum frame structure, it will like crashing the edge of the real glass and lead to the glass breakage. And here there is no such pressing at the backside. So it actually can help to enhance the mechanical load capability a lot. So here we can see from the test results. So for the same level of the deformation from the front side, the aluminum frame can withstand 5,400 Pascal from the front side and 2,400 on the rear side. While at the same level of the deformation level, the backbone steel frame, it actually can reach even to 10,000 Pascal and from the front side and 4,200 at the rear side. So for some size of the windproof module, it can pass the 8,100 Pascal static mechanical load test and also like 10 times of the dynamical mechanical load test. So we also performed the wind tunnel test of the 60 meter per second condition, which equivalent to withstanding a Category 17 typhoon. And actually, our system also is tested by the real cases. So we have an PV system installed by ourselves. So we also develop our own projects in China. So in one of the project in Hainan Island, which at the most southern part of China, and it is headed straightly by the Typhoon Yagi last year. So the Category 17 typhoon, and with the application of our windproof module and our clamping system, after the typhoon goes, the PV system is still operating normally there. While there are another system like 3 kilometer away, so using the conventional module, actually goes through a huge losses. Many of the module are blown away due to the teared off frame and mounting hole. So except for the good reliability, it also has the excellent temperature characteristic. So it has a lower temperature coefficient compared to the double glass due to the thermal dispersion ability of the backsheet, and also the operating temperature of the module is also lower. We performed one year on-site testing comparing to different module in the system, and we've monitored the backside temperature for the whole year, and we've seen in average the windproof module has a 1.5 degree lower module temperature, operating temperature than the dual glass one. And also due to the lower A side, it helped to eliminate the shading issue by the dust at the edge, so it can help to improve the hotspot issue at the edge. It also theoretically approved by the researcher. So we had in collaboration with the University of New South Wales to investigate on the impact of the JSIM technology and also the reliability of our TOPCon cell. We've seen that not only the efficiency is enhanced, also the corrosion resistance and dam heat resistance of the TOPCon cell is also enhanced significantly. So here is the empirical research performed in China by the National PV Testing Center of China. So we install the system in the Incheon city and monitor the whole year. And except for the operating temperature I mentioned is lower, and it leads to a higher power generation for the windproof module compared to the dual glass. So it's a 1.6% increased. And in the end, also the carbon emission performance is much better than the double glass. So due to the less use of the glass, and also because the steel production used much less electricity than aluminum, so the carbon emission of the backbone steel frame is much lower than the aluminum frame. So in combine of all the modules, so the carbon emission for the windproof module is more than 10% lower than the conventional module. So currently, we have already applied this structure for most of the size and power class of the module in the market. So I would like to say for the closing words. So now we are in a world where the extreme weather is a new normal. So we don't want to compromise. But with Jolywood proves that we can have it all, the high performance, the durability, and also the sustainability. So as our slogan says, the same sunshine, more value. So we would like to build up the system, not just bigger, but also better. Yeah, thanks.
That's a nice one, Wenyi. Just a question. So how's the market reacting to this the product and actually also this narrative?
Yeah, so actually we start promotion of our Windproof modules from last year, and because we also have our own projects in China, so we've used a lot of this solution in our own projects, and at the same time we are also a lot of our customers are interested in this, especially, for example, like in Southeast Asia, there are a lot of windy space. For example, in Vietnam, there's the mountain PV. It has some wind issue, and they're trying to use the windproof module. And also our clients in Europe, some area along the Alps, there's a lot of hail. Striking the system. Yeah, so they're also considering to use this. And we just commissioned one project in Europe, also for the heavy snow in the northern part of Europe. So, and we are getting more and more inquiry, especially for the hail issue in Europe. I think many client is concerning about this, and even some insurance institute is consulting us. So I think there are a lot of loss claims from the insurance companies, and they are considering for like supporting those normal conventional module for the future use, especially for the regions that has this hail issue. Yeah.
Okay, super. Thanks a lot. That was very insightful. Thanks.